As you might already know, Funkfeuer Vienna is the local community network here in Vienna, not only in Vienna, but also in Austria. And Paul asked me to get into what we're doing here in Vienna in general, and also to talk a bit about one of our bigger projects, which is about introducing IPv6 in and OLSRv2 with an existing network compared to a greenfield deployment. All right, let's start with Funkfeuer, and I've already shared a few details with you last Monday, I think it was, during the introductory event. So I will rather quickly go through this section. If you have any questions, we can catch up later. So Funkfeuer, first of all, the word is the German word for radio beacon, and the idea was that that you could think of a node like a beacon transmitting the free network, to the world around it. So that was how this name was chosen. And you also often see, like on my shirt, you see 0xFF. That's just an abbreviation, which is quite handy. Okay, we started around 2003. Nobody really exactly knows when and how. I think that's not that uncommon. Funkfeuer was started on the basis of existing hardware, because there was a commercial ISP here in Vienna who had experimented with Wi-Fi on the last mile. There was existing hardware. They terminated the project and they allowed us to use the existing hardware, which made the start much easier, of course. So that's how we started. About I think it's already 14 years ago, and yeah, let's see what happened next. So at the beginning we saw a lot of growth, because the beginning of the 2000s was the time when actually most of the ingredients were there, right, to have a community network. We had the hardware, the famous WRT45G. We had open firmware, and most importantly, I think there was also a because at the time DSL and other broadband technologies were pretty expensive, and at the time Funkfeuer really was one of the fastest ways, and arguably also the cheapest way of getting online, because it only cost the hardware. Yeah, at the time we peaked around 250 nodes. At the moment we're at around 230, so we kind of kept that level. And yeah, throughout Austria we also have some other networks were created under that Funkfeuer name. That's what a typical node looks like, and I already mentioned that on Monday. It's just the right part. By the way, I think Markus, that's your node, right? Yeah. It's not. Okay, so Markus only took the picture. It's not his node. So the right of the picture, as you all know, is one of these nodes. The left is some commercial, whatever. Sorry. I'll go back. You can also have the slides afterwards if you want. Okay, I thought maybe it's also interesting to you how we are organized, because once you have such a lot of people wanting to do the same thing, you need some kind of organization. So in Austria we chose to the form of a registered society. I think that's available in most countries, and it makes things easier because you're a legal entity. So if you want to buy stuff or have to interact with people calling themselves the same, so that's why we went with that approach. All right, yeah, second point that's also important. This concept of a society is quite well known to people, and I think this also helps, because people, I think, are just, it's easier for them to make themselves comfortable, and they know the rules and so on. So I think that also makes quite sense. Okay, in Vienna, we chose a bit of a different approach, and now we're shifting a bit towards the technical aspects. So in Vienna, we chose a concept where we have central internet uplinks, which is contrary to how other communities do it. So at the moment, we have 2 times 1 gigabit uplinks, and I think we have quite a good connection, because we have actually a direct link to the Vienna Internet Exchange, which is actually not very far from here, and yeah, that provides us with a very good connectivity also from a delay perspective. Financing, I think that's also an important topic, because in the end you need some financial resources, because there is some stuff to pay for. In our cases, of course, it's also the internet uplink we need to finance somehow, and in order to housing project. So I think it's a second basement of a building nearby, which, by the way, I think if you're interested, we can arrange for you to have a visit there. We offer housing, so people not only you don't need to have a node on your roof, but actually it's open to everyone. So you can house your 19-inch servers down to small Raspberry Pis at a, I think, very interesting price point. RPI housing, I just thought I'll mention that, because it's lots of folks have been approaching us about that. So we just introduced that recently. We offer that people can house their Raspberry Pi. They can even send it in by mail, and we will just hook it up. And it's €5 per month, which I think, so all our prices are just based on our own costs, so we just need to cover the electrical power and the connectivity, so bandwidth. I also have some photos for you, so we just completed this. These are the Raspberry Pi houses, if you will, where we are planning to accommodate them, and this is also why size is limited. For that purpose, we also built a small board. More precisely, it was Wolfgang who built that. This is meant to control the power supply, and I think control individual supply, to give people the opportunity to remotely restart their boards. Yeah, it's called switcher. All right. Our traditional network setup is based on OSPF, just for the central part of our network. This is just to connect our uplink routers to our wireless network. Within the wireless network, we use OLSR, and currently we have been using, up until now, we have been using version 1 for that, based on IPv4. We had an experimental IPv6 setup, which was also running on and instances. This worked fairly well for the past 10-something years, and yeah, with the well-known limitations, of course, and So yeah, and I think it was a bit more than a year ago that some of us just had the same thoughts. We're all, you know, in that phase where things are working well and everyone is more or less happy and saying, yeah, actually, why should we change? Never touch a running system, right, and so on. But we, some of us felt that we need to bring back that experimental feeling, right? Because in the end, we're an experimental network and not an ISP. So first of all, we all agreed it's really time for IPv6. Actually, if you deploy IPv6 nowadays, you can't really call it experimental anymore, since since it's pretty much mainstream. So we definitely wanted to do IPv6. We also wanted to overcome the limitations of OLSRv1, and having v2 available was the natural choice. We're using IBSS, so the ad hoc mode, which doesn't work that well anymore, as most people found out sooner or later. Some master-slave setups were used, which also isn't that great, also has some disadvantages, so we wanted to address that as well. And now we're at the point where I can explain why we called our project v642. Because we decided, actually it's fairly easy, we decided to go for IPv6. We knew we had to provide some transition mechanism for IPv4, because telling people we are only doing IPv6 only would have been a bit drastic move, and yeah, not everyone would have been too happy about it. And we wanted to use OLSRv2 instead of v1, so that's why we called the project that way. And yeah, in terms of IPv6, our goals were quite clear. So I think apart from the larger address space, it's one of the biggest strengths of IPv6 is its ability to auto-configure. And that's something we wanted to use as much as possible in order to make initial configuration as easy as possible. So in that case, we decided to base the main address and the OLSRv2 identifier on the device's MAC address. So that should be fairly unique, and there is a standard-based addresses for the routing protocols. This is something OLSRv2 supports out of the box, so no issue there. And then of course we also had to decide how will we partition our IPv6 space. And this was a bit back and forth, but in the end it turned out that we actually have a /29, I think, assigned at the moment. Is it 29? It changed at some point. Anyways, then we have lots of addresses available, and in the end we decided why not use this space since we already have it. And so our current address layout assigns a /48 for each node. This is quite a lot, so each node has 16 bits available to further partition the network or the assigned prefix to the owner's own discretion. I think this is quite nice. And yeah, so this is how we planned our IPv6 deployment. I think the second interesting how can I say, aspect I want to share with you is the IPv4 transition mechanism. Because for that we so why a transition mechanism in the first place? Well, I think it's quite obvious, because if you run two network families at the same time, it usually results in having two OLSR instances at the same time, and that's something we definitely don't want, because if you have two instances, you usually have twice the number of problems. Question? You know that OLSRv2 is full stack by default. You have to turn IPv6 off by configuration. Yeah. Yeah, that's absolutely true. It was OLSRv2, so the question was OLSRv2 can run both protocols at the same time. For the transition mechanism, we decided to go with IPv6 of transition mechanisms, and we decided we want to go with 4 and 6 for various reasons. And the most important reason for that was that we wanted to make use of the existing kernel implementation, Linux kernel implementation. And the idea we had was to base this on stateless tunnels, so that we don't need to care about any state between nodes where you probably have lossy links and where this could cause issues. And we also like the easy and straightforward configuration of these tunnels using just onboard tools. Yeah, and yeah, maybe before I come to the next slide, I'll share a bit more about our setup. So we tested all the setup. It was working fine based on OpenWRT and also standard Linux like Debian. This was all working fine. In our network, we not only have free hardware, or let's say, rather say free software running, we also have a group of people who like the Ubiquity software and who run the stock software, which is, yeah, it depends on the device, what particular operating system it is, but there is a device called the Edge router, and this is based on a Debian operating system to some extent. And so these guys were quite certain that, of course, this device would then support the mechanism as well. And we tried that, and this resulted in quite some frustration, because traffic wasn't really flowing and we had lots of packet loss and so on. After spending some time debugging the issue, we finally found the culprit, and this was a screenshot we took at the time. And so just to repeat that, the idea is to do 4 in 6, and this was what I think Air OS it's called. This is what the 4 in 6 kernel module came up with. So actually it's 4 in 6 in 6, and for the middle IPv6 packet, additionally there are some bits flipped in the source address part, as you can see, for some reason. Yeah, and that pretty much stopped our efforts to trying to implement that based on their stock firmware. Because in that case, with a closed source software, all you can do is, in Ubiquity's case, you can create a post in their self-support forum asking for them to fix it, but that's about it. And I think this is also still the current status of that. This is pretty much the concept we chose. I thought it it's maybe interesting or a good starting point for a conversation. These were our thoughts, and I'd be really interested in sharing with you what your input on that is, and how you did it, because obviously we're anything but done with the project. We just started with that, and I think there's lots of interesting insight behind that, what worked and what did not work. Apart from that, that's it from my side. I think I'm doing fine in terms of time. Paul is happy, so I think we have we have a few minutes left for questions or comments or whatever, if there are any. Yeah, thanks.
Questions. Anyone has questions? Yep.
So do you statically assign the public prefix to the nodes?
The question is how we do it or whether we do it?
Whether you do it or how you assign the public prefix to the nodes, and
yes.
Maybe a follow-up question, do you have one prefix or multiple prefixes?
So the current version, how we plan to implement it, is that each node has a public one public IPv6 address based on that MAC address. So we have a prefix reserved for that, where the are based on the MAC address. So that's an identifier, and that's a main address of the node. And in addition to that, we assign this /48, which is then routed to using this unique identifier within OLSRv2. Yeah, in addition, maybe there are more prefixes, because if people use this 4 and 6 tunnel, they have an additional prefix just to map the IPv4 addresses. And this, by the way, this prefix assignment is a manual task. So apart from the auto-configured address, this is something manual. And we also want to keep this manual to some extent, because we want to know who uses which prefix.
Do you use prefix delegation via the HCP v6 to assign the statically chosen prefixes to the nodes, or do you just configure them locally on each device?
No, I think at the moment we don't have any prefix delegation configured. So it's to get the prefix to the node. This is just essentially the node announces the prefix it's going to use via OLSRv2. And of course, nodes can then use prefix delegation to further distribute the address, or to further partition the address space.
Okay. Hi. So to do this, to deploy this, you have to upgrade the nodes in the network, right? Do you have access to all the nodes of the network?
Yeah, that's a very interesting question. We don't know yet. We did run some simulations in which order it makes sense to upgrade nodes. One major problem with that is with old hardware, because you need, or you also want more recent kernel versions. Often this doesn't fit into the memory, flash memory, of very constrained older devices. So yeah, that's a non-technical problem actually, how we will be able to do this transition. But yeah, it's going to be interesting how we tackle this. By the way, as part of this, I mentioned we also needed to address problems at lower layers, and part of that was that we actually found ourselves without fitting hardware, and because what we were looking for was a cheap device which can cover, so which has a high gain antenna, so an integrated router device integrated into an antenna, a cheap one which can run on OpenWRT. And during this project we also, so we found an interesting hardware, the Microtic LH-G5, if you happen to know it. I haven't seen one here, but it's a dish antenna with an integrated router. It costs about 55. So it wasn't OpenWRT compatible, and as part of that project we paid a developer a bounty to make it compatible, and it was integrated into the OpenWRT code base. So this was just a side project, and it's a really nice device, and yeah, I think it's also a good outcome as part of our endeavors.
But in the end, you have physical or logical access to every single router. Yes?
Depends on the definition of we, but yeah.
At least someone from the core team.
No, definitely not. That would be nice. But we have about 230 nodes. I don't know how many people maintain these, but it's definitely, I don't know, at least 100 people, I'd guess. Yeah, that's how community works. We will find some way. And in the end, yeah, we will probably need to, some of the nodes will probably disappear because nobody feels responsible, nobody wants to upgrade them, but that's life.
Any other questions? Maybe one last one?
Just curious, did you ever found out the root cause for the broken 4in6 encapsulation on the edge routers? Did you ever found the root cause for this? Did you manage to fix it, or?
Not that I'm aware of. I myself I wasn't involved in the troubleshooting. I don't know to what extent you can poke into this this ROS implementation. As far as I know, it's Debian based, but I guess it's not fully open because otherwise, yeah.
I was just wondering because this device features hardware offloading for like common tasks like routing or network address translation, and maybe it's the hardware offloading which is breaking packets.
Yeah, could
so
well
it would be worthwhile to try with disabled offloading if it's working fine then.
That could be an approach, yeah. We also tried, I think we tried GRE. It was broken as well. So we gave up. We decided to concentrate on the OpenWRT.
Okay, so thanks, David.
Thank you too.
And the next talk will start in 5 minutes. So let's have a short break and then do the last talk of the day, which is